Hi, everyone. My name's Chris Ayers, and we're going to talk about CI/CD and GitHub Actions today for the Python Web Conf 2023. So first, I am a senior customer engineer at Microsoft. I actually am part of Azure Engineering, the team that works and builds the Azure platform. I'm actually part of a team called Fast Track for Azure, and we are actually a free service for a lot of our Azure customers that meet some criteria, and we help them move their applications to Azure, deploy, scale their operations reliably, securely, and leveraging like infrastructure as code and DevOps. So I talk about this stuff all the time, and it gets me really excited. You can find me out on Twitter. I'm also on Mastodon, LinkedIn. I have a blog, and all of my samples and slides today are going to be out on GitHub, along with a number of my other talks. So we're going to be in GitHub a lot after this. So I do want to start out with just making sure as we go into GitHub Actions, we all are comfortable with YAML. We're going to talk a little bit about what I mean when I say CI and CD, and there might be another CD in there. We're going to go into Actions. We're going to do some high-level discussions, and then we're going to do lots of demos. I got tons and tons of demos. I'm going to show you all the power of this platform. It's phenomenal. So starting out, YAML, yet another markup language. Now, there's a couple of basic things you can see have listed them there, like lists, key value, and objects. Knowing these type of things are going to save you so much trouble. And I'm just we'll deal with them as we go through a lot of the samples. But when you have lists of stuff, they need to be like indented the same level, and you usually start them with a dash space. If you're just doing key value pairs, it's key colon space value, and then objects are some sort of name and then a colon, and then you indent, and it's the list of properties or key value pairs, whatever it might be. So we're going to see a lot of examples of those as we go through our workflows. Now, the next thing that I mentioned is CI/CD. Now, I bring this up because there's multiple definitions of CD. CI, I think we've all agreed upon, is continuous integration. Big fan of continuous testing also. But then we have, do we want to do continuous delivery or continuous deployment? And to me, the big differentiator between those is there's a human in the middle. So with continuous delivery, we have push button capability to go all the way to production. But before it ships off to production, somebody looks at it, someone approves it, someone clicks a button and does things. With continuous deployment, it's have you defined your definition of quality? Have you met your quality gate of, I want these things to compile, I want acceptance tests to pass, unit tests to pass, I want to be able to deploy it to an environment and run load tests and performance tests. And if it meets all those criteria, why shouldn't it go to production? And so if you can automate every step of that flow, why not automate it going to production end to end? That usually has for more mature environments, but all of the capabilities are here. All of the tools are here. And I will show you how you can add that manual step in and what happens if you don't. Now, actions. Actions are event driven. They live in the .github workflows folder of your repo, and we're going to see that in a moment. And they are defined in YAML. Every file is a YAML file. So we have events that trigger things, and there's a number of events. I'm going to go through them. Each event starts a workflow. So if there's an event that triggers a workflow, that workflow runs. The workflow has one or more jobs, and the jobs by default, they just run like parallel. If you have like 5 jobs defined and the workflow triggers, all 5 jobs will try to run at the exact same time. Now you can find dependencies on those, and we're going to show that. But inside of a job, there are multiple steps, and those run in exact order. So, like I said, we can have multiple jobs. So let's go take a look at some of this, because I know I'm throwing out terms, job, steps, runners. Let's go take a look at this, just to look at what we're talking about when we talk about a workflow file. So this is a very basic YAML workflow file. We've got a name, just calling it that. we have some sort of events that we want to listen to. And I'll dive into these momentarily. So this on tells us when this workflow runs. So if you're familiar with Azure DevOps, you actually have to say, I want to add a pipeline and point it at a file or point it at a pipeline. In GitHub Actions, when this file is checked into your repository, GitHub starts paying attention. And if any of these type of conditions, like I've pushed code up somewhere, or I've done a pull request, or I have a workflow dispatch, which I'll talk about, that's how we can manually do some stuff. This workflow will run. It'll get triggered. And it says, hey, I have jobs. So I have one or more jobs in this workflow. And my build job, so this is one of those YAML objects, runs on Ubuntu, and it has some steps here. I've got 2 steps, because we've got a list here. So I'm going to use a check action, and then I'm going to run a script. So let's see what this looks like out on GitHub, just so that we can take a look at that. So this is my repo in GitHub, and you can find all the actions that I've run here on the Actions tab. Now, like I said, you can have more than one workflow. So all of these workflows exist inside my repository. They all have triggered. So let's take a look at that basic workflow. So you can see I did a push. So I pushed some code, and so it triggered it to run. And there's one job, we called it build. Here's the build job. And in it, we had 2 steps. We had a checkout step, which checked out all of our code. And then we had a run step that just kind of runs a command line. And I just said echo hello world. But there's also some other steps that we see here that we didn't ask for. There's a setup job, complete job, and like a post run. And this is where things get interesting. I said each job runs on a runner. Well, I picked Ubuntu. There's also Mac, Windows, and you can actually come in here and see, okay, so this is running an Ubuntu 22 image. And hey, look, there's a link here for all the software. And I bring this up because if you've ever done CI/CD and you want to build your Python, you want to build your .NET, you want to do Docker, you want to talk to Azure or US, you need to usually install and configure tooling. Well, these runners that GitHub provides, so they're GitHub hosted runners, they come with all sorts of languages and package management and versions already installed and configured. Not only that, like we've got things like Ansible and various Git and kubectl. There's also other third parties like the Azure CLI and AWS and GitHub and Google. There's Java installed, and you can see the specific environment variables you need to reference these. There's testing tools, like if you wanted to do Selenium or Chrome. So we have those web drivers available and variables listed out. And then there's also databases. So you can pretty much use a GitHub self-hosted runner, and it'll have already installed and configured all the tooling you might ever think of needing to build and support applications. There's a number of runners out there. So I'm a big fan of the doc and find stuff. So they have a number of different ones. So you can see the specs that are available for the machines. They have not only Windows and Linux, but they also have Mac versions available. And when you have a GitHub account, you do get a number of free minutes every month to build and run applications, like to do your CI/CD runners. And then if you have a open source public, project, you can get even more. Then again, there's links out to every single image that you might need. There's other options for those enterprises that are out there that might need their own VMs or Docker images to host and build their software. You can make your own self-hosted runner and register it with GitHub. But for this purpose, we're really just going to talk about the GitHub hosted ones. Just like with Azure DevOps, you can have self-hosted ones, and that's a whole different conversation. But when we're talking about them, we do just pretty much say runs on, and you would put your your agent pool there. So that's pretty cool. We can trigger on multiple events, and I hinted that we do events. So let's look at some of the GitHub Actions events. So this is another really interesting thing. And again, the documentation is phenomenal. So what are some events that we can use to trigger our workflows running? I mean, we're going to dive in, look at end-to-end ones, but we got to get it started. Well, this is part of the list. So like a branch protection rule, like somebody's trying to push to main and you've protected it, you have to do a request in. Or they're, creating or deleting items, or we're doing a deployment. Somebody forked your repo, and that's going to trigger a workflow. Somebody interacted with an issue or added a label to a PR. Someone's messing around with the project items, so that's their work item management system, or created a pull request, or left a comment, or reviewed the comment. So we have a lot of different options. We could run it on a schedule. If nightly you want to do like a security, and then these three, I'll dive into more, but essentially workflow dispatches, I just want to go and run the workflow. I don't want to, I can manually trigger it. If you're familiar with Azure DevOps or some of those other ones, you usually can just go in and push a button to say, run this pipeline now. You actually have to tell it you want workflow dispatch in order to enable that in GitHub Actions. You have to tell it, I want to be able to dispatch workflow. You can also reuse workflows between steps, and we'll dive into that, but you need to implement like workflow call to do that. So that was a basic workflow, just a couple of steps, one job. What if I don't want it to run on every push? What if I don't want it to run on every pull request? Well, now we can use filters. We actually have a lot of control. We could say, I only want it to run on the main branch or on branches under releases / maybe I only want my workflow to run if it's tagged a certain way. So I could maybe have two different builds based on the version that we've tagged it in. Or I only want pull requests on my main branch, or I want to do a cron job to schedule it run multiple times based on a cron job. And I have the GitHub extensions installed in Visual Studio Code, and that's why you're getting some great pop-up help and links out to various things around the workflows. So it really makes working with workflows a lot easier. So that one's pretty easy, but I talked about that we have multiple jobs. So if we want to have multiple jobs, we can pretty much just list them out. I have a job 1, it runs on Ubuntu. I have a job 2, I have a job 3, and I did implement workflow dispatch. So we can go out and run an actual workflow in GitHub Actions and see what it looks like right away. So let's come down here to this basic workflow. And then because I did workflow dispatch, it even tells me, hey, this has a workflow dispatch. Go ahead and run this on my main branch. And I have a history of my previous runs, the duration in seconds, when it happened. And I got a yellow one saying this is running right now. It even shows it was manually run, manually triggered. And I can see my 3 jobs, and for some reason, job 3 finished before job 1 or 2. And I mentioned that earlier. By default, all of these will run in parallel. So if we wanted to do something like, say, compile my code, and then after the code is compiled, then run my test or run a deployment or run a scale, I can implement needs. I can show some sorts of dependencies. And as you see at the bottom here, this has job 1 running, and when that finishes, job 2 and 3 then kick off. It's very relatively simple to implement. There's a keyword that you can do, and let's go take a look at that. So when we have multiple jobs, we have this job 1 and it runs. How do I make job 2 run after? I say job 2 needs job 1. Job 3 needs job 1. And I can change this to say, hey, this depends on job. Save this. I can push this up, update dependencies. Check that in just real quick, push it up. And what we should see, if we go back up to GitHub, we're looking at this, because this had both the push and the manual dispatch, you can see that this workflow is already running again because updated dependencies, but now that job graph looks different. It's dynamically updated to show job 1 needs to finish, job 2 needs to finish, then job 3 needs to finish. So we've got a lot of power over how we can split up our tasks and move them between different states. So going back and moving on, I talked about steps. And so now I've got, and actually let's go look at what it looks like running. I've got multiple different steps out here. Let's take a look at this. I've got one job build, and in here, I've got all sorts of ways to reference things. So I've got like bash, and can just, when I do a run task, I can say, hey, echo my path. I'm on Linux runner, so CMD won't work. This is actually going to give me an error. CMD doesn't exist in a Linux runner, but like cross-platform PowerShell exists, but the Windows PowerShell doesn't exist, where I can specify different shells. I can even specify Python as one of my runners. So if I have a lot of my scripts in place and I want to implement some steps just very quickly in Python and have the runner do those directly, I can invoke that as a shell. Same with things like Perl. And then here's where it gets interesting. I have a lot of ways I can reference actions. Instead of just packaging individual steps inside my workflow or packaging scripts inside my workflow everywhere, I can start using actions that have been provided by third parties. Maybe they're provided by companies like Microsoft. We have Azure step, actions that are specific to logging in and deploying to Azure. There's Docker ones specific to deploying out to Docker. There are, in this case, these are GitHub provided, like kind of core actions, like checking out. And you can see we have 3 or 4 different ways that we can reference an action. We can look at a hash. If we know that we want a specific version of hash, in run actions checkout, and let's see what that looks like actually in the code. So it just says uses. So instead of like doing a run or doing a multi-line thing, we're using an action, and we can specify that hash. We can specify a major version. We can specify like the branch name. It kind of begs the question, how do I know these exist? Well, if you've been on GitHub and you come up here to the top, there's this thing called Marketplace. And if we look at Marketplace, there's 2 categories. There's apps and actions. For the most part, you're probably going to need apps. They're a little different, but look at actions. You can see we've got, let's look at this one in particular. We'll take it apart. So we can see it's a GitHub action. We got a version, we got a name, a description. It's a verified creator. So the creator in this case is actions. So it's a GitHub one. And we have a description of how to use it. We even have a usage. So we have some sample usages like, hey, you've checked out the code, you've made an artifact, you've done something, you want to upload the artifact. Here is a base use, like how I can copy this and put it into my workflow, and I can consume this action, or I can upload an entire directory. And so they've given you multiple different ways to use this action, along with conditional and parameters to pass in. And so it by navigating through the marketplace, you can find actions. The other thing is, if it's an action in the marketplace, it is open source. The repo is available public, and you should be able to see it. So I can come out here and I can see exactly how they implemented it. If I have a problem, I could submit a pull request. I could create an issue. All that is available because these are public actions, and you can see they have the links right here to issues or pull requests. So this is a really great way to find and discover actions out there. And I can come here. I really want to use 231. This is showing me the docs for 231 and how I implemented it for that. Very, very powerful stuff. And it gives us this great flexibility. So, we're at Python Web Conference. Why don't we look at Python? So we have some setup Python actions specifically designed to pick which version that you want to leverage. We've got a number of Python ones from the community. You can see that people have started them, they're using them. There's different options that we can all leverage. So going back, we had talked about doing these different actions. Now, one thing we noticed when we were on the documentation for upload build, and I don't know if you noticed it, but we're saying with colon and we're passing in some information. So essentially we're passing in variables or values into the actions. And there's actually a whole kind of syntax for how we can do variables. So let's just look at this one that ran a few minutes ago. So I've got a script here and it says, echo greeting name, and I'm passing in an environment and it's printing out hello world. So I'm leveraging values to pass the individual steps, and they're being passed kind of like environmental variables. So here at the top where we've done our triggers on how we want to execute our workflow, I'm saying I want some environment variables, one named greeting, one named name. And I can consume these in my scripts just by passing them like normal environment variables. Now this is for Python, or I mean for Bash, this is $greeting. If I was going to use the environment variables in something like PowerShell, I'd have to do like the $env. So however you reference your environment variables in your shell, that's one way I note them. But environment variables go kind of far beyond that, and I'll show you. So we can have environment variables or values at our workflow level, which is at the top. But then we can also define additional environment variables at the job level. So this job might override that one or be available at the environment or at the job level. And we can also define environment variables or pass things in at step level. So we can have this hierarchy of values that we can control based on our workflow, our job, or our step. So if we want to look at what that might look like, and just to quickly remind you, at this point, we're doing greeting, name from location, and we've defined location at workflow, we've defined location at the job and at the step. And so when we see what this looks like and what output it produces, it says hello world from step. So that will teach us that if we define the exact same value at multiple levels, like the most specific or the closest one to us wins. So we can override values that come from higher scopes. All right. Another thing we saw a little bit discussion of is we can do conditionals. So we can do things like equals or ifs. So we have some capability of maybe we only want to do certain steps if we're in the production environment. If we're in our dev environment, maybe we want to do certain things differently. So we can control like if the branch is equal to this, if our repo is that, if the author is this, if the pull request was successful, we have conditional control. So we can do some interesting things around conditionals. And again, the documentation, if we look at GitHub, flow conditions. So we have documentation on that. And we can dive down and see the specifics on the condition. But that lets us have more control, more flexibility in how we do things. In this case, when I come in here and look, you can see run hello, but run goodbye did not run. And if we look at why that is in our conditionals, we had said hello world. So this step never even ran because it evaluated to false. Just some very basic little examples there. And because we're now looking at the syntax with dollar bracket, very similar to handlebars, we're looking at expressions. So we have some different options for having dynamicism in our workflows. we can do formatting, so we can concatenate and do things with strings. We can do tests like, does this end with LD? Does this contain a string? Does it, if we have an array of stuff, we can do from JSON. So we can take a string from a JSON string and turn it into objects in GitHub, and then we can run like contains against them, or we can join stuff up together. So we have a bunch of options, and I just printed out some samples from those. We can take a look at this real quick, because I want to make sure that I get to the fun stuff, end-to-end workflows, just very shortly. So yeah, we can format, we can check ends with, so we can use some of these values to determine things for our conditions. Now, the other syntax that we use for that are these contexts. So we're going to have a GitHub context that is available kind of in memory in the API for our actions and our workflows to run with. We're going to know things around the repo we're working on and the branch we're working on and who triggered the action. We're going to have capabilities around knowing where we are in the job, what steps are running, and I'll talk about strategy. So if we look at context just very quickly, because this is not running in a matrix, we're not going to see much, but we can see stuff around failing fast, or the runner we're on, the directory and the caches we're working with, or the current step we're running in. Now the Git context is huge and has all sorts of information about your GitHub. And so those are used in some of your workflow tasks. So sometimes you need information from them. And just kind of continuing on how we dealt with variables, that's how we can deal with secrets. So, I'm accessing, instead of env or something like that, I'm accessing secrets. So secrets in GitHub are found in settings. You need to have certain permissions to do it. Down here under security, secrets, actions. And so just like with that variable hierarchy, you can have organization. So if you're bigger GitHub org, you can have org level secrets. You can have repo level secrets like this. So we have some repository secrets. You can have environment secrets. So we'll talk about that momentarily, but we can create environments that have their own secrets. So we can access secrets in different ways. And GitHub tries to be smart about doing secrets. So like if I've told it echo out a secret, it tries to be smart and it tries to not do that. So it's trying to hide things, but you can see, like if you manipulate the values a lot and do string manipulation on it, concatenation and stuff, it might not always find it in the values, but you can see it starred things because it doesn't want to show them. And one of these lines has stars and the other one just says name, and then the environment is starred. That's because you can pass things in two ways. You can just do the run. You can pass it in as, hey, here's an environment variable that was a secret. But that's one way we can access secrets. Secrets, if you reference something that doesn't exist, it's just going to come back as an empty string. It's not going to throw an error, so people can't kind of poke around. Now, under context, I mentioned matrices. So there is this is an example in Node where I'm building a Node library and I want to test on 12, 14, and 16. I want to test it on Ubuntu and Windows. So this is using those context and expression syntaxes we just learned to be able to do like the OS as a variable and the Node version as a variable. And this actually runs the pipeline this individual job like 6 times. 3 for the Node version, 2 for the OS, 3 times 2. So it runs it 6 times to do this. You can do similar things with Python as well. So like, let's say we have a Python version, a Python library. We can say, hey, I want to have a matrix strategy on 4 different versions of Python. And so as my steps, I'm going to use the Python version. And I'm going to pass that in every single time, and I'm going to leverage that. And it's going to use the symbolic links and pathing and environment variables to make sure I'm referencing the correct version. And if we see this live in GitHub, if we want to see what this looks like when it's run, and I go in, you can see it's made 6 different runs: the 12 Ubuntu, the 12 Windows, and it's just used the steps as kind of a template and plugged in the values to make it work. Really cool stuff. Ubuntu or .NET, I can leverage things like caching, and I can do the same thing with Python or Node or any of those, where I can go out to the marketplace, and there is an action here called, it might just be called cache. Yep. So there's a cache action that's provided by GitHub, and they actually have a ton of options. So if I look here, I can come down and, like, if I need to, do my pip caching, I have a number of different examples here where I can tell it, hey, use this key as the runner OS and hash the files and requirements. So I can leverage caches if I have multiple big steps that are all doing like a NuGet or pip. It'll cache them and speed up the restore process. So that's a very helpful thing to do. Let's look at 1 or 2 more. And yeah, Docker's installed on all of the hosted agents, which is really powerful. That lets us do things like, a Docker login using the action for Docker organization. And then we can do like a build push action where I can just provide it tags, and I can access that GitHub context that we talked about earlier to now, like the SHA hash of the current repo commit. So, and I can control push or not push. So I could do like a build locally, run some sort of tree validation or container scan, and then I could push it once I've done my scanning. Some more fun things. GitHub provides a super linter. So probably has a space. It has a space. It's always the spaces that get me. So SuperLinter is a really cool tool that you can add to any repo. And because we can have multiple workflows running simultaneously, you could, just grab the SuperLinter and drop the workflow file into your repository, and it'll scan for all your stuff. So if you're doing some structures code, you got some environment variables, you got some HTML for your docs and Markdown, you've got your Python and some scripts in Bash or PowerShell. This will lint everything all at once. And here's the provided file. It pretty much will lint everything. Now you can turn it on and off. So if you don't want to lint certain languages, you can just disable them. And it shows you all the environment variables, it shows you all the paths that you can leverage if you want to customize the linting. But this is a great way to ensure consistency in your applications. I'm using it in mine. I do have an error I got to track down. So if we go and look at my source code, you can see, oh, we got some green now. But if I go and look at some of my linter runs from a little bit ago, I had some issues. And if I look at what was going on, it took me right to the error, but it's looking for all of the things, like if I have leaks, it found Markdown, so it's scanning my Markdown. And it found I have a couple of top level things, and it actually gives me the Markdown rule, like what it is in a description, and then it looks at languages. But I can leverage this with my team to ensure consistency. I can also leverage other tooling to do security scanning if I wanted to do like Dependabot or some of the advanced security options. So there's a lot of ways that we can leverage the tools GitHub gives us to, does our code compile? Do our tests run? Is it linted properly? I have a couple of samples here, and I'll show you where we can do even beyond that. So I do a lot of Bicep, I do a lot of Terraform, I do a lot of infrastructure as code. GitHub Actions gives us so much capability. So I mentioned those events earlier. Let me go back to the events that trigger GitHub. Well, if we come down to pull requests, there's actually a couple of interesting things. We get what's happening during the pull request, like it got opened or it got closed or edited. So this gives us some really powerful tools. For instance, I could, if I wanted, and I did, set up a PR. So if I've set up a PR, this can use a reusable workflow. So it's going to automatically lint things, and it's going to use my .github workflows lint. So it's going to come here and it's going to run like a Bicep build, which is a step for linting Bicep. But then it's going to do some actions. It's going to log into Azure. GitHub uses what's called OpenID Connect to authenticate to cloud providers, so you don't need to have passwords. There's a trust between GitHub and the clouds, AWS, GitHub, or GCP and Azure. So you can just use like an app registration to link them, and they'll authenticate saying, hey, I'm your repo, this branch. But I can create a dynamic ephemeral resource group in Azure that is tied specifically to my PR number. So this is the PR number of this pull request. So I can dynamically create a resource group, deploy some infrastructure out into the resource group. And then, because we're doing on pull request. But what if we want to make sure it gets deleted when we close our request? Well, we can say on pull request closed and limit it to type closed. And we'll get the same PR number. You can just go out and delete it because it was only meant for you to go out and look at it while the PR is open. And when the PR is done, destroy the environment. So we have some really cool power in that. And so we can see how to reuse workflows by doing that workflow call, and then how to use some of these additional types and filtering to create and do requests. Now, why don't we see that? Why don't we do that? So I've got a branch here, review. I've done some commits. Let's try opening a pull request. Create a pull request. And what we should see, take it a second. I've got a couple of things all running because I told them on any pull request, but it's going to try to lint my code and it's going to try to deploy it out. And if I go out Azure, this is my Azure. I have some resource groups, but what we're going to see is, as this is running, this is pull request 3. Okay, we're talking about pull request 3. So you can see that this is, it's signed into Azure. I've done like an Azure login step. It's creating a resource group. I can see that. So once this resource group gets created, I should be able to go out to Azure and see a new resource group named like PR3, something like that. The fun of live demos, right? We did run our lint, and we can see our lint ran successfully. We had lint our Bicep code, no errors, everything's good. Oh, so we got the resource group. Let's go out to, and if I refresh this, sometimes it takes a second because it should show up right in front of these RGs right here. There, PR. So PR4. I guess I got mistaken on which PR we're talking about. Requests. Oh, it is number 4. Yep, updated Bicep. Number 4. So this is the action that's running. That last one, I guess I was looking at was the previous one. So it's pull request number 4, and it's created out in Azure a dynamic pull request 4 resource group. It's going to be deploying out my resources so that I can take a look at them. I can review them. I can see all of my checks from my pull request right here in my pull request. I can jump to this one that's running. That's a lint. Pull request validation. So that one looks like it finished deployment. We can double check. There's our code. I can go look at it and say, hey, is everything working great? If I look at my deploy step, I've even got like, I can validate it out here. So I can just click on the link. It might take it a sec to spin up, but the website should come up. You know, I could deploy, in this case, I deployed .NET. I could deploy Python. I could deploy out whatever I wanted. I could have as a validation step libraries pulled in and spin things out. There we go. Website's up and running. It's just taking a sec to probably actually spin up. But let's say it looks great. I think it looks awesome. I'm going to go in and, you know, merge my pull request. Yep, that looks great. Delete the branch. And so now if I come over here and look in actions, you can see I have really wide filters on a lot of things because I have all of these jobs running, but one in particular that's running is PR closed. So this will go in and remove those tasks. Now, I do want to be really clear. It's okay to go through and make dozens and dozens of iterations of your workflows trying to get things to work. I'm not being super prescriptive here in what you do because some organizations have a lot of CI steps that they want to do. But one thing I found that helps me is I want to test and run some of these workflows locally to make sure I have the command line steps right. I passed the right option to Python. Did I write the option, pass the right option to this? And so one of the things that's awesome is this project called Nectos, called ACT. It's by a person, Nectos. And they have made a Docker image that lets you do all of this stuff locally. And then you can just, there's ways to install on Mac, Windows, and Linux. And you can even use secret files to pass in secrets, but it's awesome. It lets you run your actions locally. And with that, I didn't see a lot of questions, but I want you to, you know, take a screenshot of this if you need to. Reach out and follow me. But one of the coolest things is GitHub.com that has all the documentation. It has samples. You know, if you're building a new project and you want to get started with actions, what you can do is you can actually just go to the actions thing in your repo, a new workflow, and there are suggestions for how to do all of these different things. So, you know, we're at Python Web Conf. Let's look at what our Python options are. And then we can say, I want to do continuous integration. Boom. I want to make a Python package. I want to publish it up. And I can hit configure. And this has on publish, hey, run these steps, set up my Python, do my pip install, push stuff out using my PyPy API. So this will help set up things and do things for you very effectively. So try things out. Check out skills.github. Follow me. You know, let's have a conversation. But I hope this was helpful to everyone. And I thank you all for sharing your time today.